All right, let's learn our next section of the normal model, where we want to find the percentages or the percentiles um, related to a certain value. Okay, so say what percentile are you in if you are this much, and the mean is here and there. Okay, so the interesting thing is when you use standardized values and then find those percentages, you can compare apples to oranges, kind of like how we did at the end of our homework lesson yesterday, because we can compare them relative to their respective group of fruit, and then we know which one is a more unusual fruit or which one is a bigger fruit or that kind of thing. All right, so the first question posed here, well, and then this is the information from the end of yesterday's assignment, that we have the gala apples, and they are represented by the normal model with a mean of 6 and a standard deviation of 1. Okay, so that's what this here is notating. And then we've got the navel oranges with a mean that are normally distributed with a mean of 7.5 and a standard deviation of 1.5. So we're asked, if I have an apple that weighs 7.2 ounces, what percentile is that in? And the orange that's 9.3, what percentile is that orange in? Well, before we get started, let's get the definition of that term percentile, which we have not talked about yet. So, by definition, the percentile is a measure that tells us the percent of the total frequency, so the percent of how much total data is at or below that measure. Now, this little at or below, it's such a continuous amount that we typically don't get hung up on it being like including equal to or not equal to, or if it just says below, that's okay. All right, so what we're going to find for a while until we get into some discrete probability, our continuous probability with our normal model, we just kind of include less than a certain point or greater than a certain point, the same as less than or equal to. Okay, less than or equal to, same. It's so finite of a difference. I mean, so teeny tiny of a difference. We don't quabble over that. All right, so let's go back to here. So here's an example. If you are in the top 10% of your class, then what percentile are you in? Remember, percentile is what's below you. So if you are in the top 10%, then you are in the 90th percentile. Okay, you can think about your heights. If you're in the 90th percentile for heights, then 90% of your peers are shorter than you. Okay, so we were asked about, so I went ahead and I have this picture here for apples and I labeled their ounces. And I have this picture here for oranges and I labeled their ounces based on the mean and standard deviation we were given for those fruits. And I put in here the question we were asked. We were asked about an apple that is 7.2 ounces and an orange that is 9.3 ounces. So interesting, they're both just a little bit above one standard deviation above the mean. All right, so we're going to learn now how to calculate this area, how to find the area under the curve now that it is located somewhere that is not on a whole number standard deviation. Okay, because if it's on the whole number standard deviation, we do the basic stuff like we know the 13.5, the 2.35, 34, 68, 95, 99.7, all of those things. But now we're talking in between. And remember, it would take calculus to integrate and find that area. So we're going to let our calculator do that for us. And so here's how we go. Make sure you have a calculator. If you don't, then you're going to struggle with this. There is a calculator app that you can get on your phone. And I think I had talked to you about that earlier in the year. So if you have a question and not about needing a calculator app, then just message me about that. All right. So here we go. When we are going to use the normal distribution, we're going to use the normal distribution on our calculator, and I'm going to show you where that is. And we're going to always use a lower bound and an upper bound. So we're going to be calculating, we have to tell the calculator the low end, the low end of our area up to the high end of the area, and then it will use that function and calculate that area in that section. Now, here is where we have this located, and then I'll talk about this statement here. We're going to do second vars, and then we're going to do normal CDF, which is the second item. So I have my calculator here. We're going to do second vars, and I'm going to use this second button here, which is norm CDF. That C stands for cumulative area. So it's accumulating the area in that section from the lower bound up to the higher bound. Okay? All right. So now, your calculator, when I pull it up, it will look like this. Okay? And make sure you have normal CDF, not normal PDF. P, I think, it's something else. I'm not exactly sure. It may be that particular point, a specific location, but we want to accumulate an area. Now, we are going to talk about this lower bound and this upper bound, but I want you to always, always, always leave this mean at 0 and this standard deviation, represented by this sigma, at 1. Those are the values for the mean and standard deviation on a standardized normal model. And we are always going to make z-scores. We'll always take context, make a z-score out of it, and then put it into here. Because of that, we always leave this at 0 and 1. And there's a reason that I do not let you change these. It's because I want you to always have that concept and continuous idea of going back and forth between z-scores and the context value. So we will do much better overall if we keep it that way. All right, so here we go. Again, we will always leave these as 0 and 1 and so on. So here we go. Let's now talk about that what we were talking about earlier. So remember, percentile is that area below. So if I want to go below an apple that is weighing 7.2, then the first thing I want to do is I want to find the z-score for that apple. So I'm going to do its x minus the apple's mean over its standard deviation. And I get 1.2. So it turns out that that apple was located, remember we said about a little over 1 standard deviation above the mean? In fact, here it is. It's 1.2 standard deviations above the mean. So to find out the percentile, then I'm going to put in the lower bound as negative infinity. Depending on your calculator, you may have an infinity button. I think that the Inspires do. But for the rest of us, we're going to simulate negative infinity. Okay, remember our normal model has 3 standard deviations up and 3 standard deviations down. Okay, well, this is saying 99 standard deviations down. So if past 3 standard deviations is crazy, whoa, what's extreme outliers? How far away is 99 standard deviations in the negative direction? That is simulating. So this negative 99 is simulating negative infinity. All right, so negative 99 to 1.2. So the way that would look in our calculator is here for this lower bound, I want lower infinity. It always goes from least to greatest. So I want negative 99 there. And then I'm going to put in my upper bound it was going to stop at that z-score of 1.2. I'm always going to leave these as 0 and 1. And so then I'm going to hit enter. If you do not have a calculator that has this menu, then you'll do this. And in fact, yours will, yours will show, yours will just show up as, let me do that again real quick. Okay, so yours will show up with just, you'll write in norm CDF, and you will have this last little part don't even put it in there. You don't have to have it in there. That's a default 0 and 1. So if you don't have that handy dandy little menu, which I actually prefer not to use it because it's just a bunch of extra clicks, you're going to put norm CDF -99 to comma 1.2, and then go ahead and close your parentheses. And then when you hit enter, it'll then, well, let's see. If I have an error like this, I always go to because I want to see what the problem is. Oh, I put a minus sign instead of a negative. Okay, let me put a negative. There we go. Now it should do it. Okay, so 0.8849. We're going to always write those to our 4 decimal places after or our 4 places after the decimal. So when I have that here, I have 0.8849. So that's, if you turn that into percent, that's 88.49% of apples are below the one that weighs 7.2 ounces. So that's the 88th percentile. We'll just round. 88th percentile. All right, let's do um, here's a different one. I have an apple that weighs 4.6 ounces. What percentile is it in? Well, here's my x value of 4.6 minus the apple's mean over the apple's standard deviation. That's negative 1.4, so 1.4 standard deviations below the mean. And so I'm going to norm CDF from negative to get the percentile from negative infinity, way down there in negative infinity, up to where my apple is located at negative 1.4. And so it is in the 8th percentile. Okay, and then this question is, why is the proportion of apples in that, why is it lower than 50%? How did I know it was going to be so lower than 50%? Well, it had a negative z-score. So it was below the mean. The mean would have, if it was an apple that weighed 6 ounces, that is the mean, and it would be in the 50th percentile. But this is one that is below the mean. So it's going to be lower than in the 50th percentile. All right, so now here's the orange. We're switching over now to the orange's mean of 7.5 and its standard deviation of 1.5. And notice it was 1.2. So it ends up being, I think I must have put that in wrong because it should be 8.8849, just like up above. And so it is also in the 88th percentile, like that apple. Okay. So now that was area below, going from negative infinity up to that z-score. Negative infinity up to that z-score. So now let's go above a particular value. So if we want to go to above a particular value, where our lower bound will be that z-score, and then we want to go up to positive infinity. Go from that z-score and then up to positive infinity, which we will represent as positive 99. Okay, here we go. So find the proportion of apples that weigh above an apple that weighs 8.2. Is it an outlier? How do you know? Okay, let's see here. So here we have the apple weighs 8.2. X minus the mean for the apples over the standard deviation for the apples. And that's 2.2. So at this point, I know it's an outlier because it's more than 2 standard deviations above the mean. And I think I wrote that over here. The apple is an upper outlier because it's more than 2 standard deviations above the mean. But let's calculate that proportion of apples higher that weigh more than 8.2 ounces. How many apples are there above an 8.2 ounce apple? So I'm going to norm CDF from that value because and then I'm going up. So I go to positive infinity. So that's represented by positive 99. And that's 0.0139. So you know what? Only 1.39% of gala apples weigh more than 8.2 ounces. So not very many. Remember that top 2.5% is our outliers. All right, proportion of oranges that weigh above. Find the proportion of oranges above an orange that weighs 6.2. So that's 6.2 minus the mean. Now I noticed it's below the mean, so I am not surprised when I have a negative standard deviation. And I have norm CDF negative 0.87 from that orange up to positive infinity. and 0.8078. So I am not surprised that this is more than 50%. 80.78% of oranges weigh more than 6.2 ounces. I'm not surprised that it's over 50% because it since it was located below the mean, since it was below the mean, then the mean, what's above the mean is 50%. So we had the 50% above the mean plus some other part above that 6.2 ounce orange. All right. Very good. So let's now move on to the next section. Now let's talk about how to go in between two values. So here we go. In between two values. So now we don't have infinity. We have two actual bounds. We have the lower z-score and the upper z-score. So we will have two z-scores. So this takes more work up front because you have to then find those two z-scores. So here, find the percent of apples that falls between a 4.5 ounce apple and a 6.2 ounce apple. So I have to do a z-score for the lower bound, which is the 4.5 ounce apple. Okay, so x minus the mean over the standard deviation. So the apple's negative 1.5 standard deviations below the mean, 1.5 below the mean. The upper one was a little higher than the mean, 6.2 minus 6. So I guess that was 0.2. And so that upper z-score is 0.2. So when I get the cumulative area, I go from the lower z-score of negative 1.5 to the upper z-score of 0.2. And that's 0.5125. So about 51.25% of apples are going to weigh between 4.5 and 6.2 ounces. All right, and then here's another example for the oranges. You can stop the video if you want to and try that. See how you're doing. Make sure you use the correct mean for the oranges and standard deviation for the oranges and so on and so forth. And there's what that comes out to be. All right, so let's summarize this. In summary, we've got area below a z-score. You're going to go from negative infinity, which what are we going to use to represent negative infinity? Negative 99, comma, up to the z-score that you calculated, where that location is. So below goes from negative infinity up to your z-score. Above goes from your data value at that z-score to positive 99, to your upper positive infinity. Probably should say positive infinity, not upper infinity. Between two z-scores, you got your the norm CDF, the cumulative area between the lower z-score and the upper z-score. All right, make sure that you've turned your context into z-scores. I even did this on my first problem. It's been a while since I've done this. So when I was doing this problem, I want you to practice these. So stop the video and practice these ones here and then check yourself. Okay. But when I did this, I went in and I think I put like I just put 76 to 85. Well, that didn't do, that didn't give me much information because if I just put 76 to 85 in my calculator, that is thinking 76 standard deviations out there. And 85, holy moly, that's way out there. Okay, so there's basically nothing out there. So I got 0. Turn them into z-scores first with this mean and this standard deviation. Okay, pause and I think there's these several problems. Do these 3 problems and then we'll come back and check them. All right. You have stopped the video and you tried these 3 problems. And so now let's see how you did. Here we were finding the area, the proportion of bananas that would be between these 2 values. So I need to find a z-score for both of these values and norm CDF from the lower z-score to the upper z-score. So here's how I did that. 76 minus the mean over the standard deviation. There's my 2 z-scores, my lower and my upper. And there's 30.66% of all banana bunches will weigh between 76 and 85 pounds. Okay. All right. Next, part B asked the percent of data above 83.6. All right, so I'd got my z-score, which I knew it was going to be more than 50% because I knew 83.6 was below my mean. So it feels natural that I have a negative z-score. Okay, and so then I go to positive infinity because it asked for above, and there it was, 64.43% of data is above 83.6. And the last one, wild hogs. Okay, I actually did look up what the average and standard deviation were for the wild hogs going crazy. So this 256-pound hog is 2.19 standard deviations above the mean. So when I do norm CDF, I want that lower area because I asked what percentile that hog is in. So I need to find how much area is below 2.19 standard deviations above the mean. So I went negative infinity up to 2.19, 0.9857. So I rounded it and I said, that wild hog that weighs 256 is in the 99th percentile of weights for wild hogs. All right, I think that's all. And now you'll go on to your unit 3, day 3 assignment. Good luck to you on that.